Hi, welcome back to Educator.com. This is the lesson on nuclear energy. Alright, so let's start out with nuclear fission. That's really what's happening to produce this nuclear energy that can be harnessed for electricity and so on. What happens is atoms, usually it's large ones, are split into two or more smaller nuclei along with byproducts. And those byproducts include neutrons, photons, gamma rays, alpha and beta particles. So the key is that they're split. And it's that release of energy. When controlled properly, the heat that is given off is used to produce electricity. So that's really how it works. When not controlled properly, you can get what's called an explosion. So there's a lot of heat generated through these nuclear fission reactions. And if the amount of heat being generated is not controlled properly with how the coolant is helping to get the heat out of the reactor, then you can have what's called a meltdown. So if you've ever heard the term nuclear meltdown, it's when the temperatures within that nuclear reactor are just going up into the thousands of degrees because it's not being maintained properly. And then you have the risk of a lot of nuclear radiation potentially leaking out into the environment. And that could make people very ill, give them cancer, or kill them. And then the effects on the ecosystem are also terrible. So yeah, nuclear explosion, don't want that to happen. So if controlled properly, it can work very efficiently. The amount of energy contained in nuclear fuel is 10 million times more than coal and petroleum. If that's hard to believe, this is actually being given to you on an atomic level in terms of the potential. So on an atomic level, it's incredible what you can get by splitting up atoms that are very heavy, atomically heavy. The one problem with that, there's a downside to this, is nuclear waste that's generated is highly radioactive, and how to dispose of that properly without harming the environment and harming people. We're getting better at doing that, but it's still a major concern. So this is a little illustration, a little graphic of the breakdown of uranium-235, neutron, allowing that split to happen, and you get various forms of fragmentation in terms of what actually comes off as a byproduct. And in the process, like I said, you get heat to produce electricity. One more thing. In the 1950s and 60s especially, you had a lot of nuclear testing by countries like the United States and Russia. So even though these nuclear bombs were being set off in the atmosphere or on islands in the middle of the ocean far away from people, there is nuclear radiation that ends up coming off of these explosions, and it goes places. Now, the farther away you are from it, the better off you are. It's not going to have as much of an impact on you. However, from some of these nuclear bomb testings, this isotope, known as cesium-137, there was a fallout of that, meaning this generation of these isotopes in the atmosphere, it came down and got absorbed into a kind of lichen. Lichens are notorious for absorbing various pollutants in the atmosphere, but this lichen called caribou moss, it's actually reindeer moss, whatever, close enough, but this reindeer moss was being eaten a lot, especially during the winter months, by certain caribou in the upper latitudes in the northern hemisphere. And so the caribou eat the lichens, and what eats the caribou? Well, Eskimos or Inuits and wolves. And if you remember from the bioaccumulation rule in terms of how pollutants end up in soils, end up in plant life, then herbivores, carnivores, and so on, you could have this buildup of this particular isotope ending up in the system of these omnivores or carnivores. And actually, some of these Inuits reported that when they tested them, they had much higher levels of radiation in their bodies than they should have been exposed to. So, even with good intentions in terms of testing nuclear weapons or using nuclear fission as a way to get electricity, there can be consequences, even beyond what you can foresee. In terms of measuring how much ends up in people, some kind of unit of measurement for amount of nuclear radiation you're exposed to, there's a few ways to do it. One of them is in millisieverts. So the way that you would actually spell that out is millisieverts. And so millisieverts per year. If you're wondering, well, what is the average person exposed to? Well, I can tell you the average American is exposed to about 2 to 4 millisieverts per year. So that's average. Now, in other countries, it may be less. In the United States, we have a lot more nuclear power plants than in other countries. So it could be less, it could be more in certain places. Also, probably depends on if you work in a nuclear facility or if you live close to one. Lethal dose, in terms of the LD50, in terms of what dose would kill 50% of people, the LD50 is equal to 5,000 millisieverts. So if you were exposed to that just in one go, there's a 50% chance that you would not survive it. At much lower levels, like in the hundreds of millisieverts, you would experience negative physiological effects, certain degrees of toxicity. So there you go. Someone like Marie Curie was exposed to a lot of radiation because of her research. Both her and her daughter actually passed away due to cancer-induced radiation exposure. Radiation-induced cancer is what I meant to say.